Good day, everyone. I'm Yunazal Aswanda, and I am part of Group 7. So before we start, here is our objectives. First is to define what is sequence and give some examples of it. Next is to acknowledge the use of sequence, and then to be able in finding a term given its position. Our title is Understanding Sequence. And then our theme is understanding how the concept of a sequence is utilized in our daily lives.
Hello everyone, I am Princess Bertrand, and after my discussion, you will learn to predict what number comes next in a series of numbers. Patterns are all around us. It could be a repeated items, shapes, images, or even numbers. And so, remember this. Number sentence is a list of numbers arranged in a row. And we call each number in a sequence a term, okay? So, what is sequence? Sequence is a group or a series of numbers that follows a certain patterns. It is fun because you have to find clues to complete them. For example, 1, 2, 3, 4. So what comes next? Yes, 5. Because we simply add 1 to the next number. And we used to count it every day. Here's another example. 2, 4, 6, 8. Now observe that numbers in this sequence are increasing by 2. So 2 plus 2 is 4, and 4 plus 2 is 6. 6 plus 2 is 8. So the next number is 10. Let us have some more example. 10, 9, 8, 7. What do you see in this sequence? What do you think its pattern? Yes, it's decreasing. So, when the number is decreasing, we have to subtract. And in our example, we have to subtract 1. So, 10 minus 1 is 9, and 9 minus 1 is 8. 8 minus 1 is 7, and 7 minus 1 is 6. And now you have it. You can now determine what numbers comes next in a sequence. So, let us proceed to our next lesson.
Hey everyone, by the way, my name is Eliza Maybibungan, and for today's discussion, I am going to discuss what is arithmetic sequence. An arithmetic sequence is an ordered set of numbers that have a common difference between each consecutive term. For example, in the arithmetic sequence 3, 9, 15, 21, and 27, the common difference is 6. The arithmetic sequence formula is a sub n is equals to a sub 1 plus n minus 1 d, where a sub n is the nth term, a sub 1 is the first term, n is the term position, and d is the common difference. For example, this is our set of sequence, so we can see that the common difference is 6. d is equals to 6. Our a sub 1 is the first term, which is 3, a sub 2 is the second term, which is the 9, a sub 3 is equals to 15, a sub 4 is equals to 21, a sub 5 is 27, and so on. To get the arithmetic sequence, you need to follow the formula. Our formula is a sub n is equals to a sub 1 plus n minus 1 d.
Hello everyone, so I'm gonna show you another example of arithmetic sequence. So the example that I'm going to show is consider the arithmetic sequence of 5, 11, 17, 23, 29, and so forth. So what is the value of the 12th term of this sequence? In these examples, we will gonna find the value of 12th term of an arithmetic sequence using the formula of an equals to a sub 1 plus
as we learn about sequence, we will come to tackle this particular sequence, which is the geometric sequence. So let us begin by giving the definition of it. What is geometric sequence? Geometric sequence is a sequence of numbers in which the ratio between consecutive terms is constant. The best way to understand it is by giving example. 2, 4, 8, 16. So how it became 4? By multiplying it into 2. 2 times 2 is 4, and 4 times 2 is 8, and 8 times 2 is 16. So to have the next term, we need to multiply it with its constant number. So our common ratio here is 2. So the formula that we will use is a sub n is equal to a sub 1 multiplied by r raised to n minus 1. A sub n is the nth term, while a sub 1 is the first term. Then r is our common ratio, while n is our term position. So let's try to use the formula.
I'm going to show you another example of geometric sequence. So the example that I'm going to show you is about how are we going to solve geometric sequence if we are looking for the common ratio. So let's start and talk about it. The example is, what is the common ratio of the geometric sequence with first term of 7 and fifth term of 112? As you can see, the solution is given. And obviously, we are looking for the common ratio with the first term of 7 and the fifth term of 112. And since this is geometric, let's use the geometric formula. A sub n is equal to a sub 1 multiplied by r raised to n minus 1. So let's go to the given. A sub 1 is equal to 7 because 7 is the first term. Next is r. R is unknown because we're looking for the r, which is the common ratio. Next is n is equal to 5 because fifth is the term position of 112. And last is a sub 5 is equal to 112. So, let's proceed to the solution. First, write the formula, which is the a sub n is equal to a sub 1 multiplied by r raised to n minus 1. Then after that, substitute it by the given numbers, which is the a sub n is equal to 112 and a sub 1 is equal to 7 multiplied by r raised to the term position 5 minus 1. So next is, let's solve first the exponent, which is the 5 minus 1. So 5 minus 1 is equal to 4. Since we are looking for the r and not with the r raised to 4, let's divide it into 7. So divide by 7 both sides of the equation. The answer is 16 is equal to r raised to 4. But the problem is that we are looking for the r and not the r raised to 4. So we need to use radical. We need to know how to use radical para mawala yung naka-raise na 4. So the application is the radical. So if raised to 4, we need to divide it into 4 para mawala ito. So let's divide it. Let's divide the r raised to 4 to the 4 in the outside. So the answer is 1. So it will be r. And that's what we're looking for. But how are we going to solve the other one? So we need to find the fourth root of 16. We need to think a one number na if you are going to multiply it 4 times by itself, the answer is 16. So we need to start to think. And I think this is it. 2 times 2 times 2 times 2 equals 16. So the fourth root of 16 is 2. Therefore, the answer is 2 is equal to r. So the common ratio is 2 is equal to r, or r is equal to 2.
Now we are down to our last topic, which is the Fibonacci sequence. Have you ever counted the petals of a flower or seen the leaves of the cacti and seeds of a sunflower arranged in both left and right-handed spirals? Do you know that those stuff are part of the Fibonacci sequence? But first, what is the Fibonacci sequence? Fibonacci sequence is a series of numbers in which each number is the sum of two that precede it. Starting at 0 and 1, the sequence will look like this. 0 followed by 1, then followed by 1, then 2, then 3, and then 5, and so on. Because 0 plus 1 is 1, and 1 plus 1 is 2, 1 plus 2 is 3, and then 2 plus 3 is 5. So basically, if you're going to observe carefully, every number in the series is the result of by adding the numbers before it. So the individual numbers is referred to as the Fibonacci sequence.
Another example is an egg. As I was cooking my breakfast this morning, I noticed that eggs also follow the pattern. The proportion of the egg shape are closely associated with the golden ratio. After shooting an egg photo, I superimposed a couple Fibonacci spiral onto it. I was pleasantly surprised at how well they lined up. See this picture to understand the association of the egg and the golden ratio.